Hey everyone, so I'm gonna show you how to do an airfoil analysis in Fluent, and I actually started it off wrong by clicking too fast, so I'm gonna let my computer do its thing real quick, and I'm gonna start over because you actually need to do this, at least the way I found to do it is in Design Claim or Design Modeler instead of Space Claim. So we're gonna let my computer finish freaking out. Hopefully it doesn't take too long. Get rid of space claim. For some reason, it doesn't let me import properly. So I'm just gonna open a new project and go to Design Modeler. Okay. Once this loads, I'm gonna click on the XY plane, concept, 3D curve, from coordinate file. So I've already pre-prepped my files. I'm not gonna show you how to do that at the moment, but essentially you're gonna need to find the data for the NACA file that you need and split it into a way that the computer can process. There's some great videos on YouTube. So after you import the first part, you're gonna generate, shouldn't take too long. Then you're gonna do another 3D curve concept, change it to from coordinates, again, select it. So now we did the upper before, we're gonna scroll back through all my wonderful files and choose the lower. It looks like this. Generate, we've got our lovely closed surface. The next thing to do, XY plane again real quick, sketch, we're gonna make it normal. Just zoom about a bit. So you have two ways to do this. You can put this in a wind tunnel, but for the scope of this project, we just need to put it in some sort of container. So that's a decent sized container. To get the data, you would want to make sure that these are centered and that your airfoil is centered really well in here to avoid any blockage effects. But for the scope of this project, I'm not concerned about that at the moment. Just for the sake of this tutorial, I'm trying to keep it semi-brief. So I'm going to do two things real quick. I'm going to make a surface from a sketch. That should make that surface. That generate. And then I need a surface from edges. And we're gonna 1, 2, click those edges, generate. Now just to be on the safe side real quick, we're gonna zoom in all the way here and make sure that my airfoil is closed. It should be closed in the front. The only place I'm really concerned is the back. It looks to be closed from this end and this angle, so I'm just gonna keep moving forward on that. One last thing we do need to do is we do need to do a Boolean, and we need to do a Boolean subtract. The target body is going to be the main body. The tool body is going to, we'll go in here and do the surface body. And then we'll generate. That gives us our nice little cutout, which is exactly what we're looking for. So now we can go ahead and close out of that and move over to the mesh. There's nothing super special about doing this mesh. You just want to make sure that it works for the body you're going for. And then I did forget to mention one thing in geometry. So I'm doing a 0 angle of attack. There's actually a way where you can rotate your body in there. So you'd want to rotate the airfoil before you make the rectangle around it. And that's how you're going to do the different rotations. It's a bit tedious because you are going to have to do it for every single angle of attack that you're looking for. So within here, it's pretty simple, straightforward the way you're going to do the mesh. It's the same way that you've been doing all the meshes, because it should be close to the end of the semester. So you're doing a sizing. Let's pick something. We'll go with an inch and see if it does it. If not, I will have to update that. And then we're gonna do inflation. Ideally, you'd want to get an inflation to work. If for some reason it's not working for the scope of this, I will omit it for this tutorial. But an inflation just lets you get a more a better idea of what's happening at a specific surface. I'm gonna just try this a different way real quick and call this airfoil. Just because I noticed it wasn't allowing me to do that name section right away, or I mean the inflation. So again, this is my body. It'll lag for a split second, but then should go through. Give it one more shot. It can honestly be really tedious, so I'm gonna go ahead and omit this inflation for now, just since it really isn't working for me at the moment. But you'll be able to get the general idea of what I'm trying to do, even if I don't include it. And hopefully it generates pretty fast. If it's not moving in a little bit, I will just increase the mesh size. Sometimes it just doesn't like the mesh size that it gives it, and it just has too much to process. That seems to be the case here, so I'm going to stop it and just change these properties. So I'm going to get this to trigger. I think the easiest way would just be to delete it and do another one. Honestly, it's so picky sometimes that if things aren't working, just delete it and start over. Let's try 2 inches. See if it'll do it then. Yeah, it looks like it's gonna do it now, maybe. So if this does fail the mesh, I will pull up another scenario that I have cached. Like it is. Okay. So ideally you would definitely want this mesh more finely. It also isn't doing it in triangles. So I'm going to give that one more go and see if it'll push through. Yeah, okay. So we're gonna rock with this for now. Ideally, you'd want the mesh to be finer, but it's good enough for the night as far as this tutorial is concerned. Real quick, bang out some name sections. You're gonna go selection, move this top bar real quick. Edges. So remember, you're gonna name this inlet. Create name section, outlet. Section, walls, and then just for kicks on this one, select an edge, select body, select this. Fluid. Okay, that's everything. Let's move this again. I don't need to regenerate because it's up to date, so I can just push update real quick. Get pushed. Go back here, set up. Forward position. I'm only using 2 processes to see if it helps it work a little bit better this time. Boilerplate, get through. Okay. Models, turn your energy on. Change this to K epsilon. You don't have to change anything else in there. Your materials, your air. And then boundary conditions at your inlet. Inlet should be 15 meters per second. Apply, close. And your outlet. Zero. Apply, close. We're gonna create 2 reports. We're gonna do a new force report for drag. We're gonna do it on the surface body, and we want that drag coefficient, so we're gonna call this drag. Okay. And then one more force report. Now we want lift coefficient. Again, lift on that surface body. Okay. Close. You're gonna initialize. Again, I'm doing a very quick initialization, so I'm only gonna do 25. Just make sure that you do enough to get it to converge. Converged. And then I'll do a very quick 100 here and calculate. And the nice thing about doing report definitions is they should auto report up. So we are going to just watch the drag report. It completed. Click OK. That's your drag. And that's your lift. It seems to be a bit off for lift, but I know there's some internal issues happening with it. I'm gonna just ignore them for now because I think it's something with my geometry, which I will continue to work out later. And then this is pretty standard. We should have a good handle on this at this point, but we're gonna click all of them and we're just gonna show you quickly how to get your plots. So yeah, like I said, obviously you're gonna want to have this a bit more refined as far as the mesh goes, but this would be what your static pressure looks like, dynamic pressure. If you wanted your velocity, that's your velocity. And then you can always change the scaling as well on these as far as that way you can change the way that it all looks. And then you would repeat this for the rest of the airfoils and get those really good plots. I hope this helps. Thanks.